Hola, Calc. Sorry I'm out today. I got a sick little toddler man here at home. But what we're going to do is do a notes via video today, and we're going to move on doing integration with U substitution. Let me start by saying this is not on your quiz tomorrow. Your quiz tomorrow is the basic integration that we did yesterday at board practice, as well as the homework that you went over today. Okay, I will be in tomorrow morning for you to answer questions, and don't forget you can also sign up for Viking time to go over stuff before the quiz. This is not on your quiz. We are just moving on like I said we would. So, integration with U substitution. We're going to start with example 1, and we're going to do it 2 different ways. So 1A, I'm going to say integrate 3 times the quantity of x squared plus x quantity squared times 2x plus 1 dx. If I gave you this problem on your quiz tomorrow, what would be your method of solving it? You should be thinking to yourself, expand it. Okay, so we can expand it. When I expand this, it's now going to become the integral of 3 times FOIL out x squared plus x. So you get x to the 4th plus 2x to the 3rd plus x squared. And then that's times 2x plus 1. Multiplying this out again. And now you might be thinking to yourself, please no, do not put one of these on our quiz tomorrow. And which I'm going to say to you, don't worry, there's not. You might have to FOIL something out, multiplying a binomial times a trinomial, and then distributing this 3. No, I'm not that mean. A little crazy sometimes, but not like that. Alright, so we are expanding this all the way out, and I'm hoping I'm not making any mistakes here. Whoops, and I should have been carrying down this dx all the way. Fixing that. Okay, so we get all the way to here. And I'm saying, integrate this guy. And you're like, all right, Ms. Gutierrez, I got this. That's x to the 6th plus 3x to the 5th plus 3x to the 4th plus x to the 3rd. And don't forget your constant. To which you would say, great, done. And normally you would. I'm just going to manipulate this to kind of make it a little easier when we do part B. So, taking a look here, I'm going to factor out that GCF of x to the 3rd. That gives me x to the 3rd plus 3x squared plus 3x plus 1, leaving that constant on the outside. Now, you might notice, okay, the x cubed plus 3x squared plus 3x plus 1 might resemble Pascal triangle, the 1, 3, 3, 1 bit. If not, I'll just go ahead and tell you that that is actually x plus 1 to the 3rd power. Again, that constant hanging out on the outside right there. Okay, moving on to the next page. Keeping that in mind, I can actually write that as x times x plus 1, both of those to the 3rd power. And come on. Okay. What you can't see is that close to the top of my iPad does like a little drop-down box, and it's being a gigantic pain. So let's try this again. Off to the side over here. Parentheses, x times x plus 1, parentheses, parentheses, everything to the 3rd power. Okay? So, seeing what we have here, what we did is we said x to the 3rd times x plus 1 to the 3rd is 2 things together, both to the 3rd. And I can just actually distribute that, which is x squared plus x, all of that to the 3rd, still plus our constant. You might be thinking to yourself, why is she doing this? Okay, here we go, part B. We're going to try it again again, the problem was the integral of 3 times x squared plus x squared times 2x plus 1. All right, so we're going to do the title, U substitution. So I am going to let U equal x squared plus x. Then we're going to take the derivative of U. We'll call that du, and that would be 2x plus 1 dx, because we're taking the derivative of U with respect to x, going on over here. So then you'll notice, oh, there's my U, there's my du. So what I have now is the integral of 3 u squared du. And you might say, okay, I can take the antiderivative of that and integrate that, and that's going to give me u to the third plus c. Here's the thing. You can't leave it in terms of u. So there's one extra step involved here. We're going to take this u and plug it back in, so our final answer becomes x squared plus x quantity to the third plus c. And so right now, you should be noticing that this answer, right here, is the same as this guy up here that we did the long manipulation of in part A. So what this does is it allows us to not have to expand and deal with the craziness that we did in part A. Let's go on and do another example. Here we go. All right, numero dos. The integral of x to the third plus 3 quantity to the fourth times x squared dx. Okay, again, we have to come up with what is u. So the first thing you want to figure out is what part of the integral is going to be your u. So I'm going to let u equal, you want to look for the function whose derivative is in the problem. So in this case, u is going to be x to the third plus 3, because that's going to give me du to be 3x squared dx. Now you might notice, okay, I have the x squared dx right here. But what I don't have and what I'm missing is this 3. Okay, we can totally fix that. We just put a 3 right here. Whoop, right there, 3. You might be thinking, Miss Gutierrez, you just multiplied the whole problem by 3, and you can't do that. You're right, I can't. But I can multiply by 1. And how do I make 3 into 1? I put it over 3. So if I multiply by 3 inside and the 1/3 outside, it's like I'm multiplying by 1. So now I have the full derivative of 3x squared dx. And this now becomes 1/3 of the integral of u to the fourth du. Leaving that 1/3 on the outside, I have 1/3. This guy becomes 1/5 u to the fifth plus our constant, which you could say that's 1/15 u to the fifth plus our constant. And you might think, I'm done. And I'm going to say, no, you're not. Back to reality. We have to replace u. Now, when I say that, guys, I mean replace you in the problem, because you as an individual are not replaceable. Not at all. We love having you here. Never replace you. Here we go. That's our pretty little answer right there. Any questions? Jot them down. We can talk about this after the quiz. Mr. Sankey might also be popping in to answer some questions for you guys also. So write them down. Number 3, let's go again. The integral of the cube root of 5x minus 1 dx. Okay, u substitution. You need to do a u substitution anytime that you're dealing with a function whose derivative is not 1. So, we're going to come off to the side. I want you to think for a second. What should be our u substitution? What should we let u equal? I hope you're thinking 5x minus 1, because that's what I'm thinking. Because then that makes our derivative 5. And you might be thinking, but there's no 5. That's okay. We put one in there, right there. Hello, 5. But if a 5 goes inside, what goes on the outside? 1/5. And if you need to, get different colors like I have going on here. All right. So then, this comes out to being 1/5 of the integral of u to the 1/3, 1/3, hello line, du. And you take the antiderivative here. That's 1/5 times 3/4 u to the 4/3 plus our constant. And don't forget, you can multiply these guys together to get 3/20. Replace u. And take it to the 4/3 power, slap a plus c, and you're done. Any questions? Hopefully things are getting a little bit better going on here. All right, let's kick it up a notch, okay, guys? Number 4. Let's go with the integral of x squared sine, that looks like a 5, but it's a sine, of x to the 3rd dx. Okay, you might be thinking, ooh, what should we make u? Okay, you got to give it some thought. Because if you make u the x squared, what's du? 2x, not in the problem. Okay, you might be thinking, oh, sine of x to the 3rd. Not a bad guess, except for what's the derivative? Cosine, and there's no cosine there. So actually what we're going to do, because I have x to the 3rd and x squared, is we're just going to let u equal x to the 3rd. Because then that makes du 3x squared dx. So we got the x squared. What's missing? The 3. Good. So 3 on the inside, 1/3 on the outside, because you have to multiply by 1. And what that means is we now have 1/3 of the integral of sine u du. And now you're thinking, what's the antiderivative of sine? And that 1/3 stays on the outside. We have negative cosine u plus our constant. Hi, that's a plus sign, not an and, people. Sorry for the sloppy handwriting on the iPad. And that becomes cosine. U was x to the 3rd plus c. Slap a pretty box around it. If you have questions, jot them down. Okay, moving on here. Number 5. Let's go ahead and do the integral of 3 sine to the 4th of 2x cosine 2x dx. All right, as we do more of these, the hardest part is identifying what should u be. And we have a lot of stuff going on here. You might be thinking, okay, maybe it's 2x. The derivative's 2. We don't know anything that has the antiderivative of sine to the 4th cosine. Let's try again. Okay. Maybe we do something like sine x. Okay, well, it's sine 2x, so try again. And you just got to play with it. You want to look for what are you going to let u equal? So what can your du help you cross out? So we're going to let u equal sine to the 4th of 2x. Rewind. I got carried away there. Just sine of 2x, not sine to the fourth. I just started copying stuff down and didn't even think about what I was saying. All right, rewind. U is going to equal sine of 2x because that is being raised to the fourth power. So what we're actually looking at here is a u to the n problem. Now if u is sine 2x, then we have du. What's the derivative of sine 2x? You might be thinking cosine 2x. Don't forget the chain rule here, people, because it's cosine 2x times 2. Or 2 cosine 2x dx. And you're thinking, okay, what do I have going on here? I have the cosine 2x here, so I need to input in that 2. If a 2 goes here, then I have to put a 1/2 on the outside. So what does this problem now become? 3/2 the integral of u to the fourth du. Okay? So now, that's 3/2 parentheses 1/5 u to the fifth plus our constant. We can multiply the 3/2 and the 1/5 to go 3/10, excuse me, and then replace u. So that's sine to the fifth of 2x plus our constant. Remember, it's sine to the fifth of 2x, not sine of 2x to the fifth. So you got to be careful with that. All right. We'll do a couple more together. I'll give you some you-dos where you can just pause it and come back to it. And we'll go from there. X squared over the quantity of x to the third minus 1 squared dx. All right, so what are you going to let u equal? Remember, the idea is to let u equal something that the derivative is already in the function, so it goes away. In this case, x to the third minus 1. You're starting to probably see that a lot of the u's are what is in the parentheses being raised to some power. Okay? So here we go. That would make du, taking the derivative, 3x squared, dx, of course. So then when we go back in and we rewrite this, okay, we're missing the 3, so I can just jump right to putting that 1/3 on the outside, and this becomes 1 over u squared du. The more we do of these, the more you want to get in the habit of not have to writing out every single step of putting the 3 with the 1/3, or maybe not writing out what u and du are, but I'm not expecting you to do that right now. It's going to take a lot of practice, and that's okay. So then from here, we get 1/3, and now if you need to, you can rewrite this as 1/3 the integral of u to the negative 2 du. That's 1/3 u to the negative 1 over negative 1. I'll just put the negative 1 in front, plus our constant. Or that becomes negative 1 over 3 x cubed minus 1 plus our constant. Now you could have replaced the u and still left it as a negative exponent. That's fine. You are not required to simplify unless the directions tell you to. So just remember that you can leave it as the negative exponent. That's totally okay. All right, one more together. 7. This is the integral of the quantity 1 plus 1 over x to the third times 1 over x squared dx. Okay, so think to yourself, what are we going to let u equal? Now, this problem, a lot of people say, let's let u equal 1 over x, because they think that that will give you the derivative of 1 over x squared. And you're not wrong, it does help, but that doesn't eliminate the 1, because you can't have 1 plus u parentheses the third. So the whole thing right there has to be u. 1 plus 1 over x is u, and that'll let du be negative x to the negative 2. So this now becomes the integral of, oops, I wanted to switch back to the black ink. Sorry about that, guys. There's only so much I can do to be colorful and have fun when I'm talking to an iPad and no one else. Alright, so this is the integral of u to the third du. Am I missing something? I am. Tell me what it is. That negative sign, because there's no negative up here, so I'm going to move it to the outside. So then I have negative 1/4 u to the fourth plus your constant. But you can't leave it like that, so we say negative 1/4 parentheses 1 plus 1 over x to the fourth plus our constant. All right, here we go. 3 u-dos, and we'll call it a day. So we're going to go with the integral of cosine 5x dx. We're going to go with the integral of e to the 4x dx. And we're going to go with the integral of sine x e to the cosine x dx. Go ahead, pause the video, try these 3, and then we're going to come back and you can move into the next page and we'll check all of the answers. Welcome back. Let's check your answers. Number 8 was the integral of cosine 5x dx. Hopefully you made u 5x because the du would be 5 dx. And then you're thinking, but I don't have the 5 dx, so put the 5 in there, the 1/5 on the outside. And I'm dealing with 1/5 integral of cosine u du. All right, antiderivative of this is 1/5 sine u plus c, or 1/5 the sine of 5x, slap that sucker in parentheses, plus our constant. Next one, number 9. The integral of e to the 4x dx. Let u equal 4x, because then the derivative, your du be 4, with the 1/4 on the outside. That gives you 1/4 the integral of e to the u du. We love e to the u because it's just e to the u. And so we get 1/4 e to the 4x plus our constant. And the last one you had was number 10, which is the integral of sine x e to the cosine x. Okay, now in this case, hopefully you let u equal cosine x, because then your du would have been negative sine x. You don't have the negative, so you put one there. But if you put one there, you're going to have one on the outside because you have to multiply by 1, not negative 1. That changes things. And so we have the negative of the integral of e to the u du, which is just e to the u plus our constant. But we have to replace the u. And so we get negative e to the cosine x plus c. Okay, if you have any questions, ask me when I get back in tomorrow, or you can ask Mr. Sankey if he pops over. Keep in mind again, this is not on your quiz. Your quiz is just the basic integration. You are going to have homework tonight on this, page 338. numbers 17 to 20, along with 22 and 23. We'll be going over this after your quiz. Okay? I hope you guys have a great day. Remember to see me tomorrow morning or tomorrow during biking time before your quiz. And I'll see you soon. Bye, guys.